Chapter 2, Exercise 30. Hints. Show the equivalence of the two statements, then prove the second statement using Theorem 227 and the corollary to Theorem 236. In this exercise, we consider Ik as a Euclidean space. Solution. First, we prove the equivalence of the two statements. Assume the first statement holds. Let G1, G2, and so on be a sequence of dense open subsets of Ik. Define Fn equals Gn complement for n element of n. The set Fn is closed, Theorem 223, and has empty interior for each n element of n. Indeed, by exercise 9d, this, and so Fn circ equals empty set. By the first statement, Ik doesn't equal this. It follows that this. Conversely, assume the second statement holds. Let F1, F2, and so on be a sequence of closed subsets of Ik such that this. Define Gn equals Fn complement for n element of n. The set Gn is open for each n element of n and this. By the second statement, there exists n such that the set Gn is not dense in Ik. Gn bar does not equal Ik. By exercise 9b, this, meaning that Fn circ does not equal empty set. In other words, Fn has a non-empty interior. Now, we will prove the second statement in its stronger form. Let G1, G2, and so on be a sequence of dense open subsets of Ik. We will show that this is dense in Ik. It is sufficient to prove that every non-empty open subset of Ik contains a point from this. Then, for any a in Ik and any delta greater than 0, we will have this. So, let U be a non-empty open subset of Ik. The set G1 is dense, hence U intersection G1 is a non-empty open set by Theorem 224c. Let A equals this and delta greater than 0 be such that this. Define U1 equals n delta of A. We note that this. For every point B element of U1 bar, there is C element of this, and thus the following, meaning that B element of this. Assume we have constructed a sequence of neighborhoods U1, U2 up to Un, such that this, since Gn plus 1 is dense, it follows that Un intersection Gn plus 1 is a non-empty open set. As shown above, there exists a neighborhood Un plus 1 such that this, allowing our inductive construction to continue. Thus, we obtain a sequence of neighborhoods U1, U2, and so on, such that this, in particular, U1 bar, U2 bar, and so on, forms a sequence of non-empty compact sets, Theorem 241, with the nested property here, since this. By the corollary to Theorem 236, there exists a point C element of this, then C element of this, and for every integer n greater than or equal to 2, we have C element of this. Consequently, C element of this, and thus this. Therefore, the set here is dense in Ik. Comments. With a slight modification of our approach, one can prove Bayes' theorem in an arbitrary complete metric space. The notion of completeness is discussed in Chapter 3 of the book. Thanks for watching.